Assalamualaikum, Bismillahirrahmanirrahim. And the topic we will discuss today is the signal flow graph and its application. As we have studied earlier, signal flow graph is also a technique to represent any complex circuit, and it has two component branches and nodes. Now, in today's lecture, we will study how to simplify a signal flow graph into a single transfer function, and we will use a technique uh, called as Mason rule. Basically, Mason was the name of scientist who invented the technique to simplify a signal flow graph. So, the Mason rule is the transfer function of a system that represents the signal flow graph is given by, and the formula the Mason proposed is written here. It's G, the transfer function is equal to C of S over R of S, means output over input, that will be equal to summation of K, and Ek delta T over delta. What is that K? K is the number of forward paths, means if there is a signal flow graph, it has one forward path, 2, 3, 4, whatever the number of forward path, we will sum the these forward path. Let's suppose we have 3 forward path. We will write this in as T1 delta 1 plus T2 delta 2 plus T3 delta 3 over delta. Okay, what is delta K? Delta K is again the number of forward path, and delta is written, delta can be found as delta is equal to 1 minus this delta is equal to 1 minus summation of loop gains plus non-touching loop gain taken 2 at a time minus non-touching loop gain taken 3 at a time plus non-touching loop gain taken 4 at a time, and so on. If there are 5 or 6, then we will proceed as minus summation of non-touching loop taken 5 at a time, and plus non-touching loop gains taken 6 at a time. Actually, it will the sign will come in alternate way. First it's plus, then minus, then plus, then minus, then plus, and then minus, and so on. And what is the delta K? Delta K is the delta minus the loop gains term in delta that touch the kth forward path, means, yeah, or we can say summation formed by the eliminating from delta those loop gain that touch the kth forward path. It means delta K can be found by delta minus those forward path that or those loop gain that are touching the forward path. We will not write here. We will write here only delta minus of summation formed by the eliminating from delta those loop gain that touch the kth forward path. If it's a first forward path, we will consider from the first, and the second, for the second we will put the second, and so on. Let's solve an example so that the Mason rule will be more clear to you. So here is an example. Now, by using the Mason rule, we have to find the transfer function of the given signal flow graph. First of all, we will have to find the forward path. In this case, as you can see, we have only one forward path, G1, G2, G3, G4, and G5. There is no other way in which we can reach from input to the output. The terms non-touching loops or loop gains, you are very familiar with these terms, as in the introduction of signal flow graph I have explained very well about all these terms. So first of all, we have to find the delta K and delta and T of 1, T of 2, and T of 3, and we will put all these values in this given transfer function, and we will get the simplified signal flow graph. So first we have to identify the forward paths. So as we have seen that here in this case we have only one forward path, and it's G1, G2, G3, G4 and G5. Now we have to identify the loop gains. As you know very well what are the loops that start from the same node and end at the same node. So in this signal flow graph or SFG we have four loops. Uh, one is the this loop. It start from the this node and end at the same node. So loop gain will be G2 H1. Second one is the G4 and H2, and the third loop gain is G7 H4, this loop gain, and the last one is the G2 G3, the biggest loop, G4 G5 G6 G7 and G8. This will be the fourth loop. There is no other loop except these four loops, so we have identified the loop gains. Okay, now what we have to identify? We have to identify the non-touching loop. What do we mean by non-touching loop? As we have studied earlier, non-touching loop means the loops which don't have any node common. So these are the loops we have found earlier. So the non-touching loop, as mentioned in the formula for delta, it's equal to 1 minus summation of loop gains. Loop gains summation of four loop gains will come here, plus non-touching loop taken 2 at a time minus non-touching loop taken 3 at a time and non-touching loop taken 4 at a time. So first we will take non-touching loop taken 2 at a time. So loop 1 and loop 2 means G2 and H1, and loop 2 G4 H2. These are the non-touching loop as they don't have any node common. So the L1 and H2 H1. Okay, any other non-touching loop, these two, this one and this one is also non-touching loop. Loop 1 and loop 3, and loop 2 and loop 3 are also a non-touching loop, but the loop 4 is not a non-touching loop with or any loop, because it is the biggest loop and it has either 1, 2 or 3 or more nodes common between 1, 2 and 3. So these are other non-touching loop taken 2 at a time. Now we will take non-touching loop taken 3 at a time. And what about 3 at a time? We will multiply loop gains of loop 1, loop 2 and loop 3. These are the gains of the loop 1, loop 2, loop 3. We will get the loop gain taken 3 at a time, and we will get this result. Okay. Is there any non-touching loop taken 4 at a time? No, because the fourth loop is having common node with loop 1, loop 2 and loop 3. So this term will not come. Okay. What is the delta? And as we know, delta is 1 minus summation of loop gains. These are the four loops. We have written the loop gains, then plus summation loop gains, summation of loop gains taken 2 at a time. These are the loop gains taken 2 at a time, minus summation of loop gains taken 3 at a time. So we have done this and we have found here, plus loop gains taken 4 at a time. So there is no such 4 loops in this example which can be taken at a time. So this will be delta. And what is delta k? And delta k is, as I told you earlier, that it's 1 minus the loop gain that is not touching the forward path. So this is the only one loop that is not touching the forward path, that is G7 H4. So delta k means delta 1 equal to 1 minus G7 H4. As there is only one forward path, so it will come only delta 1. If there are two forward paths, that it comes delta 2, and 3 for third forward path, that it comes delta 3, and so on. So now we have found all the unknown values. We know the T of k means forward path gain. We know delta k means delta 1, and we also know the delta. Now we simply put all the values, and we find the transfer function. So it's delta, it's delta 1, it's T1. We have already found these values in the previous slides. So G of S or transfer function will be equal to output over input G1 delta 1 over delta. So we simply put all the values we have found. This is the forward path gain, this is the delta k1 minus uh, uh, loop gain of the system, and loop gain of the loop that is not touching the forward path over delta. So this is the transfer function. We can replace this signal flow graph by simply putting say, R of s at one end, and this the gain of system on the branch equal to C of s. So this technique was invented by the Mason. So this is called the Mason rule. So you can practice Mason rule by solving practice problem and problems. I have written two practice problem for you. One is this. In this case, we have only one forward path: G1, G2, G3, and G4. And second term will be the non-touching loop. And or how many loops are there? One loop and two loops, and here comes the third loop, and here comes the fourth loop. Four loops are here. One is the minus one, other is the G4 minus 1, G3 G4 minus 1, G2 G3 G4, and minus 1. Or instead of putting minus 1, you can simply multiply it with the minus. Similarly, delta k, what is the value of delta k? Delta k in this case you have to find. So similarly, in delta will be the 1 minus summation of loop gains plus loop gains taken, summation of loop gain taken 2 at a time minus loop gains taken 3 at a time, and so on. So similarly, it's a practice problem for you again. You have to find the g of s by using Mason rule. Here comes only one forward path: G1, G2, G3, G6, G7. No other forward path, so it will come G1 delta 1 over delta. So you have to find delta 1 and the values of G1, delta 1, and delta. So do the practice of these two practice problems. It will be more clear to you. For you can also solve your practice problems and problems from your book, and if you feel any difficulty, you can ask me in the comment section, or we will discuss in the upcoming live lecture. So that's all about today's lecture. In the next lecture, we will study we will try to solve few more examples on the block diagram and signal flow graph. Okay, take care of yourself. See you in the next lecture. Allah Hafiz.